students, today we read class 9 mathematics chapter 8. Topic is quadrilateral. In our previous classes we learned many properties of quadrilaterals. Today we will read midpoint theorem. Here, the line segment joining the midpoints of two sides of a triangle is parallel to the third side. When a line segment joins to the midpoints of any two sides of a triangle, it becomes parallel to the third side. How it can be proved? Here it is given us one triangle and it is joined in any line segment, the midpoints of two opposite sides, any two opposite sides. And we have to prove that line segment becomes parallel to the third side. Let ABC is any triangle where the midpoints of AB and AC is given as E and F. It is given any triangle ABC where E and F are the midpoints of AB and AC respectively. To prove, here we have to prove when we join these midpoints E and F of the sides AB and AC, this EF becomes parallel to BC. Here EF parallel with BC. To make this EF and BC parallel, we have to construct, we have to produce this EF and a line from the vertex C should be drawn which is parallel to AB that will intersect the produced EF. Construction. Draw a line from C parallel to BA, which will intersect EF produced at D. Now we have to draw a line from the point C that will parallel to AB. And this line, which is parallel to AB, intersects the produced EF at point D. Now it is constructed. This line parallel to AB, which intersects the produced EF at D. From this construction, we have to prove this EF and BC both are parallel. How it can be parallel? How can you make them parallel? If we can prove BCDE is a parallelogram, then we can prove BC and ED both becomes parallel. Because in case of parallelogram, opposite sides becomes parallel. If BCDE is a parallelogram, then we can show BC and ED will parallel. If BC parallel to ED, then BC also parallel to EF. Now we have to show that BCDE is a parallelogram. How can it be a parallelogram? First, to make any quadrilateral as a parallelogram, if we can show the both pairs of opposite sides are parallel to each other, then that becomes a parallelogram. Or if any one pair of opposite sides, if one pair of opposite sides are equal in length and also parallel, then the quadrilateral is said to be a parallelogram. If any one of which the data is given for this, then we can show that quadrilateral becomes a parallelogram. So we have to show any one conditions out of which two, then we can make this BCDE is a parallelogram. It is not given us this BC and ED are parallel. We have to show it. So we can't show that both pair of opposite sides are parallel. So come to the next condition, that is any one pair of opposite sides are equal and parallel. Can we make them equal and parallel? If we take BE and CD, if BE and CD becomes equal and also parallel, then we can say BCD is parallelogram. It is already constructed that this AB and let it be CE. This CE are parallel. AB and CE are parallel. If we can show BE and CD are also equal, then we can say this BCDE is a parallelogram. If BE and CD are equal and parallel, then BCD is parallelogram. But we have only BE and this CD are parallel, as AB and CE parallel. Since BE and CD are parallel already, then we have to show BE and CD are equal. And we can show this BE and CD equal only one condition, when we prove these two triangles congruent. If these two triangles will congruent, then AE and CD will equal by simplicity. If AE and CD equal, but AE equal to B, then CD and BE also equal. In that condition, we can say BCD is parallelogram. But we have to show triangle AEF and triangle CDF are congruent. To make these two triangles congruent, we have to check whether we have the data for making congruent by any congruency rule. So what type of data we have here? Here AE and CE both are equal because it is given AF and CF both are equal because it is given F is the midpoint of AC. So AF and CF both are equal. Next, these two angles are equal. These are vertically opposite angles. And the third one, since it is given these two lines are parallel, so this angle and this angle both becomes equal as they are alternate interior angles. By angle side, both the triangles are congruent. By AAS, the triangles becomes congruent. When we cut these two triangles congruent, then AE and CD becomes equal. This implies BE and CD also equal. If BE equal to CD and BE parallel with CD, then BCD is parallelogram. Let's write. In triangle AEF and CDF, angle AEF is equal to angle CDF. Alternate angles. Next, AFE equal to CFD. That is vertically opposite angles. And AF is equal to CF. Because F is midpoint. Now triangle AFE equal to triangle CFD. Triangle AFE congruent with triangle CFD by angle side criteria. Since both the triangles are congruent, so AE and CD becomes equal. AE and CD, AE equal with CD by CPC. AE and CD both are equal, but AE is equal to BE as E is the midpoint. Since E is the midpoint of AB, so AE and BE both are equal. Since AE is equal to CD, this implies BE also equal to CD. Here BE and CD both are equal. Since BE parallel with CD and BE equal with CD, so BCDE BCDE is a parallelogram. H B parallel with CD and B equal with CD. B parallel with CD and B equal with CD. So B C D E is a parallelogram. So BC parallel with ED. This implies BC parallel with EF. Since BCD is parallelogram, so BC parallel with ED. This implies BC parallel with EF also. It is proved. Let's do one more theorem. The line run through the midpoint of one side of a triangle. Parallel to another side. Bisect the third side. It is given a rectangle in which a line is drawn from the midpoint of any one side and that will be parallel to any other side, and we have to show that line will pass through the midpoint of its third side. Let it is given any triangle ABC. In which the midpoint of AB is E, and we have to draw any line from this midpoint E parallel with BC. Here is the midpoint, that means AE and BE are equal. Now it is drawn AD, that will parallel with BC, which intersect AC at point F. Now we have to show AF and CF are equal. That means F is the midpoint of AC. It is given any triangle ABC where E is the midpoint of AB and ED parallel with BC. Now we have to show F is the midpoint of BC. Or it can be written as AF is equal to CF. We have to show this AF is equal to CF. Now construction. Draw a line from this point C parallel with AB that intersect ED at point P. Here it is done CQ which intersect produce here are this ED at point P. Draw CQ parallel with D that intersects ED at P. Here, this CQ intersect ED at the point P. Now we have to prove. How we can prove? This F is the midpoint of AC. If it is proved AF and CF both are equal, then F is said to be the midpoint of AC. So how can we make this AF and CF equal? If we take triangle AEF and triangle CPF, if these two triangles are congruent, then easily we can say AF and CF are equal. By this, F is said to be the midpoint of AC. So how can we make both the triangles congruent? That is the question. How these two triangles are congruent? Here, these two angles are equal because they are vertically opposite angles. It is constructed with two lines parallel, AB and PQ. Both are parallel. So this angle and this angle both becomes equal by alternate interangles. Next, this A and BC, if which two sides become equal, if they become equal, then by angle side we can make both the triangles congruent. So how can we make this AE and CP equal? Just come to this BCPE. In our earlier or the previous theorem, it is proved. This BCPE is a parallelogram. How it is parallelogram? In this condition, this AB and QC, it is constructed parallel and it is given EP and BC parallel. So BE parallel with CP and EP parallel with BC. Which two are parallel? It is given. Which two are parallel? It is by construction. By construction, which two are parallel? It is given. Which two are parallel? So BCPE is a parallelogram. Since it is a parallelogram, then BE equal with BC, but BE equal with A, so A equal with BC. Let's write it. Since AP parallel with QC, this implies PE parallel with CP. EF parallel with BC and EF parallel with BC. This implies ED parallel with BC. BCDE. Is a parallelogram. BCP is a parallelogram. Since BCP is parallelogram, so B and BC will equal. B equal to CP, but B equal to A. This implies A equal to BC. Now we have to take triangle AEF and triangle CPF. In triangle AEF and triangle CPF. AEF and CPF. Angle AFP is equal to angle CFP. They are vertically opposite angles. Now angle AEF is equal to angle CPF. Alternate angles, and it is proved A is equal to BC. So triangle AEF and triangle CPF are congruent. AEF congruent with triangle CPF by angle side criteria. Both the triangles are congruent. So AF is equal to CF. Since both the triangles AEF and CPF, both the triangles are congruent, so AF is equal to CF by CPC. Since AF and CF both are equal, so F is the midpoint of AC. This implies F is the midpoint of AC. It is proved. If we take any triangle, let ABC is any triangle, and the midpoints of AB, BC and AC, and it is E, F and G. If we join all these midpoints on the three sides of the triangle ABC, then the triangle ABC is divided into four triangles, and all these triangles are congruent to each other. How they are congruent? Since these two are midpoints, they join with this AB, so these two are parallel. These two are midpoints, join with BC, these two also parallel. Now DFC, DFDE is a parallelogram, and the diagonal of a parallelogram divides the parallelogram into two triangles, which becomes congruent to each other. Similarly, CDEF, this one also a parallelogram, because these two are parallel and EF are midpoints, it becomes parallel with AC. This AC parallel with EF. So CDEF is also parallelogram and DF is the diagonal. So this triangle and this triangle are also congruent. And AEFD is a parallelogram where D is diagonal. So this triangle congruent with this triangle. In this way, all these four triangles are congruent with each other.